Welcome GeoTrig. This is video 5-1, verifying trigonometric identities. The essential question is how to use fundamental trig IDs to verify identities. Fundamental. Let's begin. So here's a bunch of identities. I know it's a lot, but you probably know most of these. Reciprocal ones, the sines and the cosecants, I think you know pretty easily and you've written down before. Quotient identities are basically tangent, cotangent. You know those. Pythagorean, you might have seen these before and wrote them down in former notes, but you probably forgot them. I'd write them down. Write these ones down again. And there's even and odd identities. I don't think these are as important. But Pythagorean identities, these are going to be really important, and I don't think you know these well, so make sure you write these ones down again. The rest you know. So we're going to use these identities to verify other identities. What does it mean to verify? Well, we have this example, cosecant of x times tangent of x equals secant of x. Now, you have to verify that. So the goal is to get both sides of the equation to be the same thing. Like I want to break this down so it's like cosine of x equals cosine of x, or secant of x equals secant of x. Whatever. They just have to be the same thing. So you're going to manipulate each side independently. So you might manipulate the left side only, or maybe the right side, or maybe do a little bit of both. So, but you know, it just depends on the equation. And there's a few rules of thought to this. The first is you start breaking down the more complicated side. In this case, clearly that side has two things. Maybe you break down the left side first. Some other rules. So not only just break it down more complicated, break things down into sines and cosines, because those are easier to manipulate. And also know those Pythagorean identities, especially this one, sine squared plus cosine squared equals 1. That's used so much. And its other little forms right here, 1 minus sine squared x equals cosine squared, and 1 minus cosine squared equals sine squared. So know these identities just whenever you see sine squareds and cosine squareds, especially being added and subtracted, think that maybe we're going to use one of those identities. So let's try some examples. I'm going to go to that first example and verify the identity. So when you're doing this, make sure you leave a lot of room for work, and I kind of put this so you can work in the left or the right. So what I'm going to do is I'm going to break this down into sines and cosines. I know that cosecant is the same thing as 1 over sine. And when I'm breaking these down, I'm not writing the x's because I'm just trying to avoid the work. And that's going to be times tangent is sine over cosine. And I know secant is 1 over cosine. All right, and again, I don't need to put the x, I'm just doing the work. So now, since these are being multiplied, you can cancel matches on the top and bottom. The sines cancel out. So I have 1 over cosine of x is going to equal 1 over cosine of x. Hey, look, these are the same thing. So I've just verified that identity. All you have to do is this last step. You get both sides the same, you're done. That's it. Let's try a different one. So I'm going to verify this identity. Now, okay, left side's more complicated. But the first thing I might do, and there's always you try a few different things. You might say, hey, look, you can factor out a sine of x on both sides, on the left. So I'm going to factor out a sine, and you're left with 1 minus cosine squared equals sine cubed. All right? 1 minus cosine squared, I go back to those Pythagorean identities. One of those identities said 1 minus cosine squared equals sine squared. So we're going to use that and change this to sine times 1 minus cosine squared, another sine squared, equals sine cubed. Well, this is one sine times 2 more sines, so that's sine to the third of x is going to equal sine cubed of x. So they're the same thing. And we're done. I only manipulated the left-hand side. Let's try another one. So I want to verify this identity. It's looking even more complicated. Well, if I see two fractions here, I want to combine these into one fraction, because there's only one fraction on the right side. So the first thing, I got to multiply both these fractions by the common denominator. So I'm going to multiply the left one by sine over sine, and the right one by 1 plus cosine of x on the top and bottom. 1 plus cosine of x. Okay, I know it's messy, but bear with me. So what you have on the left here, and I'm going to spread this out, I have a sine times sine of x, so sine squared of x equals sine. Okay, and the denominator is going to be the same. They're both going to cancel. So I'm not going to bother writing that. So I have a sine squared in the x for the first fraction. Actually, I'll just write out the steps for you. Never mind. So sine of 1 plus cosine plus, and it's 1 plus cosine of x times a 1 plus cosine of x, so it's a 1 plus cosine of x squared over sine times a 1 plus cosine. Same denominators, and then equals whatever. And the same denominator, so I'm going to combine that. So I get sine squared plus 1 plus cosine squared all over sine times 1 plus cosine. All right, equals whatever. Now, what can I do next? Let's expand out this binomial here. So it's going to be sine squared plus, I'm multiplying two of these together. It's going to be 1 plus 2 cosine plus cosine squared all over sine times 1 plus cosine. Wow, yeah, a lot of work still. Again, but let's start manipulating this even more. On the top, I'm going to get rid of the parentheses. They don't matter. So we have a sine squared. I'm going to rearrange this. So it's sine squared plus this cosine squared plus 1 plus 2 times cosine over the same thing. Now the neat thing, I got to get my page extender here because this is going to be a lot of work. The neat thing about that is you know what sine squared plus cosine squared, you know that's going to be 1. So this part right here is going to combine to 1. So what I have is 1 plus 2 cosine over sine times 1 plus cosine. Alright, and again, this is going to be 2 plus 2 cosine over sine times 1 plus cosine. Alright, and that equals what I've lost track now. There's so much work. 2 cosecant of x. Alright, we're getting closer. I'm going to factor out that 2 on the top. So I get 2 times 1 plus cosine, and see what's happening, over sine times 1 plus cosine. And what happens over there on the left side of that fraction is those cancel, so I'm left with 2 over sine. Now what happens over here is I can break out cosecant, actually breaks down to 1 over sine. So it's 2 times, this is 2 times 1 over sine, which is the same thing as 2 over sine. So guess what? 2 over sine equals 2 over sine. I'm done. I had to do a lot of work, I know. That was a ton of work. But that's what it took to get that done. Let's try one more. So verify this identity. Sometimes you work the left and work the right. So I'm going to start working the left first. Now you're going to multiply to combine these to the same fraction, right? I'm going to speed up and do some of these steps in my head. So the first, combining these to the same fraction, you multiply the left side times 1 minus sine of 0. So 1 minus sine of 0, or sine, and then you multiply the right one times 1 plus sine. So it's going to be plus 1 plus sine. And the denominators are going to be 1 plus sine times 1 minus sine. It's kind of like a difference of squares type thing. If you actually multiply those together, you're going to get 1 minus sine squared. Okay, because 1 plus sine times 1 minus sine. It's going to be 1 minus sine squared. Do the math. Alright, so what's neat about that, hey, I know what, on the top I can combine that 2, and the signs cancel out. So 2 on the top, 1 minus sine squared. Okay, that could get cosine squared, right? Alright, but we got this mess going here on the left. Well, I can rearrange that to 2 plus 2 times tangent squared. That I can factor out a 2 and write that as 2 times 1 plus tangent squared. Okay, what's 1 plus tangent squared? I'm going to go back to my identities here. 1 plus tangent squared equals secant squared. Okay, so we're going to use that. So it's going to be 2 times secant squared. Well, secant squared is the same thing as 2 times 1 over cosine, cosine squared. And that can be written as 2 over cosine squared. And hey, on the left I have 2 over cosine squared. So guess what? They're the same thing. We're done. That's it.